So today's lesson deals with the logarithmic functions. We're going to have to rewrite logarithmic to exponential, exponential to logarithmic. Now the first two examples are going to be like, huh? But you need to understand example 1 and 2 so you can be able to do example 3. So this is the formula. That is the same thing as that. It's just written in a different form. So first thing we need to know is this is called a base. This is called your exponent. And the x is the answer or the argument. That's what it is. Question so far? So this is the same thing as this. Do not be confused. Do not be told otherwise.
Wait, so y is exponent?
Y is the exponent and b is the base. Okay. So for the first example, we need to rewrite logarithmic to exponential. Let's look at A. We have 2 equals log. Now please understand this number 5, which is the base, it's a subscript. So it's towards the bottom. It's not the same size as the other one. And so it's going to look a little bit weird, but it's not that weird or that bad. When they give you the problem, you need to label it. Labeling it will keep you from making careless mistakes. So the thing that's by itself is labeled with a, this is my y. Who's my b? This is my b, and the x is the x. So when they say, can you please rewrite this as exponential, well, who's my b? 5. So we have 5 to the y power. Who's my y?
2.
2 equals to x. That's your answer.
So would x be 25? Or
If we have to solve for it, yes, that's what it would be. That's all you have to do. And the problem 1 is like example 1. So this is your y, this is your b, and this is my x.
So it's like what it gives us, we turn it into the second.
Yes. So you're getting it in logarithmic, you change it to exponential. So who's my b? B. Who's my y? 3. And who's my x? 64. Now, for the first problem and second problem, you're just rewriting. When we do the following 8 problems, or 7, those you actually have to solve. So the last one, do it on your own. I'm going to pause this, label it, rewrite it. So they wrote it differently. So just don't label just YBX just because. So this is what I have. Is that what you got?
Mm-hmm.
Yes? Questions? No? Okay, for example number 2, we're doing it the other way around. Rewrite exponential to logarithmic. So these are the other 3 that we're going to be doing the other way around. So once again, you label based on this, and then you rewrite it. Sure. So the 12 would be my b, this is my y, and this is my x. So when I rewrite this, which is 2 equals log with a little 12 and then x. Hard? No, right? So b is my b, my exponent is y, and this is my x. So the next one would be
3 equals log b 8.
Log base b of 8. And this is my b, my y, and my x. And this is y equals. So who uses logs?
The logarithmic
People. But in real life, the people who need to know about logs and natural logs, and I told the class on Wednesday, but I don't know if it was this one, but it is the people who study earthquakes. The people that measure the magnitude of an earthquake, they have to know how to work really good with logs, because that's what they use on that scale to determine the magnitude of it. Okay? So, first two problems, there it is. Are we good? Okay, example 3, there is going to be 9 parts to it, but they're easy. I know you hear 9 and you're like, oh my god, that's so much, but it's going to go by pretty simple, believe me. So we have to evaluate. When they say evaluate, that means we need to find the answer, but we're going to have to do it without a calculator. So the most important thing I need to know right now is I need to use this. So from the front part of the notes, I still need to know how to use this part. So problem A, it's going to look something like this. So if we recall the part of the logarithmic, that was set equal to who? To y. They're not going to give it to you, so you have to do that on your own. Like set it equal to y. Now, this was my b, and this is my who? X. So now I have to rewrite it in exponential form. So this would be
2
to the
y
equals to
32.
32. 2 to what power gives me 32? 2 to the fourth is 16. So it's to the 5. So 2 to the second, that's 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. So 2 to the fifth is 32, which means y equals 5. And that's what we're trying to figure out. In the next problem, what is the value of what? So, like I tell you, we're going to do 9 different types, or 6 different for sure, solving for y. And it's just because there's different scenarios. So log base 6 of square root of 6. I have to set it equal to who?
Y.
To y. I label, this is my b and this is my x. So when I rewrite this, this is
6 to the y equals square root of 6.
What could y be in this problem in order for 6 to the y to be the same
negative?
thing? But 6 squared is 36. It's not that. What's the reciprocal of 2? 1 over 2, which is a half. Didn't I tell you the value of the square root is 1/2 before? So if I do 6 to the 1/2, it's the same thing as having the square root of 6. Now let's say I had the cube root, then this would have to be a what?
1/3.
A 1/3. Very good. So what is the value of y for this one?
1/2.
I threw in the 1/3 just so you can understand. 1/2 equals, the square root equals 1/2, but if it had a 3 here, then this would be 1/3. If it had a 4, it would be 1/4, depending on the situation.
As long as the base is the same number as inside of there?
Yes, they would have to be the same in order for that to be true. Log 5, we set it equal to y, so this is b, this is x, so the problem would be
5y equals 5.
what would y have to be in order for that to be true?
1.
1. So 5 to the first power, is that 5? Yep, so that means y is 1.
It's pretty easy.
It is, but there's different situations, so this is why we have a lot of parts in it. So let's say we have log base 16 of 4. So we set it equal to y. We label this as b, this is y. This is x.
16y.
16 to the y equals to 4. What can I do to the 16 for it to be equal to 4?
1/2.
Why 1/2?
Because that's the square root of 4.
Oh, that's the square root of 16, and the
yeah,
square root of 16 is 4. Very good. So if 16 we put a 1/2, that's the same thing as having the square root of 16, which is a 4. So that means, yes, y is 1/2 also. So let's look at E. Log base 7, 1. We set it equal to y. This is a b. This is an x. What do you think the answers could be here?
7y equals 1.
What does y have to be in order for it to be 1?
A negative? Square.
Any? 0. Very
Oh,
good.
there you go.
Anything to the 0 power is always going to be 1. So in this case, it's a 0. Log base 9, 9 to the 7. Set it equal to y. So I'm going to pause this and try to do that one. Let's see what you get. So they all look different. It looks like it's going to be hard, but it's actually pretty simple. So when I rewrite it, I get 9 to the y equals to 97. So what does y have to be? 7. Because your bases are the same, I just need my exponents to be the same. So it's 7. Boom, I'm done. Are we good with that? Questions?
No.
So you're going to have one of each of these. You're going to have 6 problems like this. The 7th problem is going to be like the next 3 examples. So you're going to have one of each. So let's look at G. Ln 5th root of E. Now Ln is very similar to logarithmics. Now log means logarithmics, Ln means natural log. Now the natural log and the E are inverses of each other. So what does that mean? When they're next to each other, they cancel each other. So the only thing that I have left over here is my exponent. What would have been the exponent of E? If it's a 5th root, it's actually 1/5.
Isn't that Ln?
Yes, because there's a 1 here even though we don't see it. So let's look at another one just because it's pretty simple and it's Ln, the cube root of E squared. So what would be your answer for this one?
2/3.
2/3 is correct. So the 7th question with this is what it looks like. And the last one here, that's I, Ln, the cube root of E to the 5th. 5/3, yes. So, are we okay with that?
Yes.
Yes? Perfect. So after these, I think we're at problem 9 right now, problem 9 or 10. Example number 4 deals with the graphing. We're not going to graph anything. I just need to make sure you know how to plug it into the calculator. So you do need a graphing calculator if you still don't have one. graph the logarithmic function. And we're just going to do 3 examples just to practice the plugging in. That's it. And of course, you know, in your assignment, those are really easy because you type it in and then you just compare the graph and that's it. So when we look at the first one, this is the first problem. Now, we've covered transformations, moving left, moving right, moving up, moving down. Where do you think this graph is going to move? To the left. Very good. 5 left. So let's go ahead and graph this. So if I grab my graphing calculator, has everybody found log on the computer? I mean on the calculators? It's right there. So we have to do control 10 to the x, so it pops up. Now if you see, it opens up the little spot for the bottom. So we put a 3, and then we put an x plus 5. Does it move to the left 5? Yes, it does. Yes, it does, because originally it should be here. So my only worry is, do you know how to put the numbers? That's just it. Yes? Can you see it? We're not writing anything. It's just you practicing typing it in. Are we good?
Yes.
Yes? Okay. How about you type this one in? So I'm going to type it in the same one just because I'm going to press tab. Control log 1/3. You could even put a fraction down there. Do not be like, oh my gosh, why am I doing that? Now this one, it completely goes the opposite way. Now the reason it goes the opposite way is because your x is what?
Negative.
Negative. So that's why it kind of opens in the opposite direction. So are we good? Yes? And the last one for you to practice how to plug it in is the ln one. -2 minus ln x. Do you know where the ln is at?
Oh, yes.
It's right next to it, right? So graph -2, control e to the x, that pops it up. Now when you do ln, there has, oh I forgot the minus, right? Sorry, thank you. So when you do the ln, the natural log, you need to make sure it's in parentheses. And just so you understand why it's important, because yesterday I had a student, if I delete the parentheses, it becomes ln x. And it's like, if I try to graph that, it's not, I can't. So there has to be a parentheses around whatever is next to the ln. So we do that, that's what the graph looks like, so everybody see it. So we're good. So 3 questions of graphing. The last 3 questions, so that's up to you 12. 13, 14, and 15 are going to be like example number 5. So example 5. Find the domain. In order for me to find a domain, I have to do what? What do you use to help you find a domain? This one's different. If we were doing work from last semester, yes. You have to graph it. So in order for you to be able to find a domain, we have to graph. So you have to use a calculator for the last 6 problems for sure. So I would say do those 6 problems first, but the choice is yours. Make it a great day or not. I'm just kidding. So we're going to graph this. Now, what's different from this one and all the other problems we've done?
There's no base.
There's no base. When there's no base, it's understood to be a 10. So if I don't put a base because they don't give me one, and I do x plus 2, the calculator automatically knows, hey, it's a base 10. So when no number appears there, the calculator and you should know it's a base 10. So when I put this here, there it is.
or?
Huh?
Like, we
You don't have to.
Okay.
I didn't do it, but it popped up because the calculator knows it's a 10. If you want to, you can. So the question here is, what would your domain here be? Where does the graph start off at?
-2.
At a -2. To what?
Positive.
To positive infinity. Why do you think it starts at a positive, at a -2?
Because the 2 is positive.
Because the 2 is positive, and that makes it move to the left too. So all you have to do, hey, oh, but wait, there's a question to be answered. That's an infinity, and I'm sorry it looks so crappy. But would it be parentheses or brackets?
The 2 would be...
Does it equal 2 or not? So where do we go to know if I have to change that to a bracket or not? We go to the table, and I'm going to look at a -2. And the calculator's not liking me. At a -2, what does it say? Undefined. So does it equal 2? -2? No. So it stays as a parenthesis. So just so you know, look at -3, -4, -5. What does that mean? Is there any part of the graph right there? No, there isn't. So it starts off at that -2. So let's look at B. F of x equals log x minus y. So you might be able to do this without a calculator if you understand what's happening. What do you think the domain, and I would encourage you to challenge yourself and kind of write something and then graph it and see if you're right. What do you think the domain for this one's going to be?
5 for positive 5.
For a +5, which way?
For the
Which infinity? Do you think to the negative?
To the positive.
You think to the positive? Let's find out. So, this is it, right? Yep. And it starts off at 5 and it goes on to positive infinity. So it would be 5 to positive infinity.
what would make it negative?
A ver, let's find out. If my x is negative, does it go the other way?
I see.
And it changes everything because everything is kind of multiplied. So you would need that right there. But good questions. That's what y'all need to do. Change your logarithms.
Why'd you put the negative?
Oh, I don't know because you guys kept saying negative. But yes, it's to positive infinity. I apologize. So it is 5 to positive infinity. Please make a correction if you were writing what Miss Peña was writing. F of x equals log base 7, 64 minus x squared. So you're going to have a question like A and B, you're going to have a question like C and D, and you're going to have a question like E and F. So I'm doing 2 examples of each question, the last 3, because I don't want for you to make a careless mistake or say Miss Peña didn't go over this, I have no idea what to do. So when I graph this, it looks completely different. Have y'all graphed that?
No.
Not yet? Almost there? When I graph 64 minus x squared, this is what I get. So it looks really different from A and B and all the other ones we did in the other examples. So what is your domain for this problem?
Oh, there's 2 domains. Wait, does that mean that there's 2? No.
It's connected, so there's only one domain. It goes from a -8 to a +8. Would it be parentheses or brackets?
Brackets.
So we go to the table just to double check. -8 is undefined. So parentheses, +8 is undefined, so it's parentheses. So it happens from a -8 to +8. What's the square root of 64?
8.
Oh, maybe that's why it's 8.
Ha ha.
Ho ho ho. Oh, sorry, Christmas is over.
Huh.
So what do you think this answer is going to be without plugging it into the calculator?
4, 4. -4, 4.
And I'm going to plug it in just so you can see it. You don't have to, but this is what it would be. So does it go from a -4 to a +4?
Yes.
Yep.
So the base has nothing to do with that?
Nope. The base does not affect
What if
that.
it's a plus x?
I don't know, but the one on your assignment is
Square root?
it's a positive. It's a negative like this. Oh,
Whoa.
something completely different. But the one on your assignment is with a minus x squared. Okay? So E, f of x equals log x plus 1 over x minus 3. So graph this one, for sure the first one. The second one you don't have to because it's going to be different from A, B, C, and D. So log base. We don't have to put it. What's the base?
10.
10. Very good.
So we could just skip over it or just put 10?
Skip over it or put 10. Exactly. So this one, it splits into 2. So when it splits into 2, my domain is going to have what in between? The U. Remember the union this and this. So it's coming in from negative infinity and it stops where?
At -1.
Negative 1. So it looks negative infinity to a negative 1 union. Where do you think that negative 1 came from? The plus 1 on top, right? And then it starts off where? At a?
+3.
Oh my God, where do you think that positive 3 came from? From your denominator. So the numbers in the equation are going to help with your domain and range. So let's just throw the last example, and this is it, and we're done. So we have f of x equals log x plus 2 over x minus 5. So what do you think this is going to be?
-2.
Negative infinity.
-2. Union. 7. Positive.
Okay, so let me just graph this just to verify that we're right, because now we're geniuses. We don't even need a calculator.
Heck yeah.
What? So, does it start off at a -2, negative infinity to -2? Yep.
Yes.
1, 2, 3, 4, 5, 6, 7, 7 to infinity. Hombre. We don't need calculators. Let's go pound them off.
LOL.
All right, so we're done with the lesson. That's it. Those of you who are watching the video at home, stay tuned to next week. You should be able to do it, most of it, without a calculator.